Hello, everyone. It's Mike Kezdi, Managing Editor of Trenchless Technology Canada magazine. I'd like to thank you for joining us for the 6th Canadian Underground Infrastructure Innovation Center Academy Webinar, HDD and Sliplining and RTP Pipe, a dual approach, presented by Alois Multerer, Account Manager for Radlinger PRIMUS Line GmbH. Organized by the Canadian Underground Infrastructure Innovation Center, CUIIC, the University of Alberta, and Benjamin Media Inc., CUIIC Academy offers classes, courses, webinars, and events to help further underground infrastructure educational opportunities across Canada. CUIIC Academy webinars cover a variety of pressing topics related to the underground infrastructure sector. Speakers include industry-leading professionals who provide a monthly free educational webinar to the public, followed by a question and answer period. Please join us next month, July 20th, for our next installment of the CUIIC Academy Webinar Series, Dewatering and Trenchless Construction, presented by Stephen DeBas of Stantec. In addition to this webinar series, we will be holding the CUIIC Safety Academy this November in Edmonton. For more information on these events, please visit academy.cuiic.ca. I'd like to take a minute to thank M-Pipe for sponsoring the 2023 CUIIC Academy Webinar Series. Please contact Hannah Stakulich for more information on becoming a sponsor. At this point, I'd like to turn the discussion over to Alois. Take it away.
Thanks, Mike. Welcome the audience to our presentation for CUIIC here based on the gas sector, this time around for HDD, sliplining, and RTP pipe. RTP piping, a dual approach, quite new. We do that in Europe a lot at the moment, and so that's why we want to bring this over to the North American market, especially here in Canada, as we have many river crossings, many crossings that we have to go through. So pay attention and fire away. The quality system is obviously manufactured by Radlinger PRIMUS Line Germany. It's coming from there. We do have a standalone system here that absorbing the internal pressure all by itself. The independently tested by the GTI, which is the Gas Technology Institute in Chicago. Our system obviously is DIN norm, ISO norm, and API 15S norm for the folks here in North America certified. Burst pressure absolutely holds it by itself. The service life is 50 years plus, fabric factor of 2. It's always divided burst by 2. That gives you the service life factor, and divided by 2. That gives you the MOPs for your gas line. And of course, when there's water, it's 1.25. This approach here is not just for the gas sector, but also for other sectors that I will get into. In the gas sector, our liner basically consists of an outer layer abrasion-resistant PE sheet and the reinforcement for the hoop strengths for the RTP pipe, which is a reinforced thermoplastic pipe, comes from Kevlar. Kevlar is known, bulletproof vest, etc. We call it Aramid Fiber. Aramid, of course, is 4 times stronger, equal tensile strengths as our pipeline rehabilitation system consists obviously of liner and of connector. So based on that, that's what we call a system. We are mostly using this approach for the medium pressure and pressure ratings, I want to say between 100 psi up to about 400, 500 psi in the diameter range of 6-inch DN 150 to about DN 400, which is about 16-inch. So that's the diameter range. So the PRIMUS line technology, as you guys can see here, consists of the flexible high pressure liner, patented end fittings. That makes the PRIMUS line system. The liner and connectors are developed in Germany. We are at it since 1995 at the gas sector, slip lining gas pipelines all over Europe, for that matter, for now. In North America, as we are coming to the market, API 15S, GTI. So at this point in time, we are getting into this market with our RTP system. Now, PRIMUS line is a trenchless technology. Obviously, for most of you folks out there, trenchless is the method The installation procedure, as you can see, from pit 1, let's say, to pit 2, it's a PRIMUS line drum with the liner. It gets inserted into the hose pipe, winched through from pit A to pit B. Yeah. The longest section we currently have done is about 3.2 kilometers or 9,600 feet in one shot. So that gives you a good range against, let's say, other options out there if you would have to fuse HDPE pipe together, or we have this in one shot. So the method is trenchless and sliplining. Those are the two important parts to understand. So the combination, and this is where it becomes more technical as the approach goes further, the combination of HDD, which is horizontal directional drilling, and RTP piping, the PRIMUS line. The hose pipe is created using the HDD procedure. The hose pipe is constructed in this case. Now I used like a DN 300 12-inch pipe. So the benefits of the using an HDPE pipe as an HDD drilling and then sliplining our PRIMUS line ISO 9080 standalone system, there's many benefits to this. This is what I'm bringing to the audience rather than having a steel pipe. I will get into this a little bit later in the presentation. So if you have a hose pipe constructed, and let's say you have an HDPE pipe with a bend radius, as you can see here, these are technical details, versus cast iron pipes versus steel pipes. By using HDPE pipe, we reduce the working area and save costs. And by installing the PRIMUS line liner into the HDPE pipe, which was drilled before, we increase the working pressure of the HDPE pipe. So you could do that for gas, you could do that through a force mains, you could do that for pressure pipe applications where you would use that kind of method. So gas is not the only one where we do it, but in this case, we're going to talk about natural gas, that is. So the liner installed in this case, as I'm going through this presentation, is a PRIMUS liner DN250. That would give you about an MOP for the water sector of about 30 bar, which is about around the 400 PSI. In gas, obviously, it's 18 bar we do about, so you multiply that by about 14.5 per bar, so you are around the 300 pounds pressure. Of course, we could do that for oil as well. Oil is a tricky situation. Most oil pipes, as we have seen, are still steel. Water and natural gas, we see more of HDPE drilled with PRIMUS line as a pressure holding liner. So this slide here now, phase 1, let's say, as we go through, is pit 1 to pit 2. As you can see, the HDT is using a machine in which is flexible rods are rotated and pushed, propelling a cutter through the ground. Drilling fluid is pumped through the drilling rods to drill the head where high pressure jets and the drill bit will grind to the soils ahead of the drill stem. The drilling fluid will also carry the cutting backs to the entrance pit at the drill machine. It is also serving to cool the cutter. So this is describing a little bit of the HDD method. The drilling fluid is a mixture of water and usually bentonite and polymer. So at first we got to drill the hose pipe from A to B in a siphon. So interdirectional drilling thing, you can see, for example, here, when you use HDPE, in the debeading end of it, we see a lot of that, and we have our own opinion towards that from a technical aspect of it. We actually leave that out. We don't go into it with the debeading machine. We don't like it debeaded. Obviously, we have a reason for that. Most people don't do that well, we find. So actually leave it the way it is fused is for us the best. The second step is enlarging the drill hole to the size sufficient to safely install the selected pipe. So the reamer is pulled back and rotated while pumping drilling fluid to cut and remove solids to enlarge the hole. In the case of a difficult geological subsoil condition, several phases with the reamer and increasing the diameter of the reamer are required, with empty drill rods being attached behind the reamer for the intimate expansions. The expansion diameter of the pilot hole should be at least 30% larger than the outer diameter of the product pipe, so that there is sufficient bentonite and drill cuttings, swellable mixture of bentonite, soil, and clay, for an all-around and force-locked embedding of the pipe. So this again explains the HDD. Phase 3 of it. Phase 3 of the horizontal directional drilling part is the last step, is pulling in the selected pipe into the previous enlarged hole. The drill rod and reamer will be attached to the swivel, rotation joint, of course, which is placed between the pipe and the reamer to prevent any torsional stress from the rotating drill rods being transferred to the pipe. As the selected pipe is pulled into the drill hole, drilling fluid is pumped downhole to provide lubrication to the selected pipe. Horizontal directional drilling workshop here, as we're doing it, the working steps with a new pipeline to be drilled to be pulled in. The pipe that will be pulled in can be made of different pipe materials such as high-density polyethylene in our case. Of course, for most of you out there, they know that you can HDD ductile, you can HDD, a lot of it is steel. In this case, HDPE is the choice. Working steps. The drill pipe lengths between pit 1, pit 2 must be constructed in the area around pit 2. The pipe shots made from steel and HDPE are welded together. So when we connect back onto the grid, this is where this comes in, and this is where I'm going to show you later what we use for this as connectors. And from cast iron are coupled together. The pipe must be constructed in accordance with the general accepted rules of technology, and for most of us understandable. Before starting the pulling in, a pressure test, tightness test must be done. The constructed pipe must be placed on rollers along its entire length to facilitate the process of pulling the pipe into the drill hole and to reduce the friction on the pipeline, and at the same time to reduce the pulling force required for pulling the pipe. So here, for example, you can see the HDD machine. It's about a 10-ton unit. And this track of the pilot hole can be done using a transmitter or steering tool located near the drill head, which sends a signal to the location engineer giving the exact coordinates of the drill stem. Readings are constant. Corrections will be made by the operator if needed. The speed of the drilling pilot hole is done, and upon reaching the exit point, the beacon housing and bit is detached. The horizontal drilling further on phase 3 with a smaller drilling machine, product pipes with outside diameters, in this case from 50 millimeter up to 600 meters, can be pulled through the drill hole. The individual sections are up to 500 meters. So most river crossings I can see we do are anywhere from about 50 meters on up to, I think the largest we've done is the River Rhine at 452 meters in one section. Depth is usually between 8 to 12 meters, as the locating capability of the drill head transmitter is limited to this depth. More than 90% of HDD systems manufactured and in use belong to the class of small and medium-sized drill machines up to maximum of 25 tons. So if somebody has questions towards these slides, please make sure that you put that on the bottom and we'll answer them a little bit later. Slide 24, horizontal directional drilling. As you can see, we're dealing with an annular space. That means the hose pipe, in this case HDPE, the liner being PRIMUS line RTP, will have an annular space. That annular space or annular gap can be monitored. That's a maintenance procedure, yeah? So for straight sections of the hose pipe, the distance must be equal to or greater than 1 millimeter in order for us to put the liner inside the HDPE pipe. Yeah, so we do not do tight fit, as it's called in the jargon. For a hose pipeline laid with bends, the distance must be equal or greater than 8 millimeters. Obviously, when we negotiate bends, and PRIMUS line is a flexible material that can negotiate bends up to 45 degrees, we need to have about an 8 millimeter annular space. So here is a project, for example, at the River Rhine. We have a 450 meter shot, HDD inserted hose pipe, SDR11. We put in our gas liner, which is a MD300 or a 12 engine for North America. In this case, placed under the River Rhine for numerous reasons. You can, for example, here for the audience, as you can see on the right side, that one that gives you all the little points, the connector core with welding end, the external sleeve, the steel pipe end for pressure testing, the connector to connect the positions, electrofusion connector, hose pipe made from HDPE, and fitting for monitoring pipe. So for the people out there in the gas sector, I think we're quite familiar with what that means on monitoring annular gaps. Any questions, obviously our engineering team will assist you in that. Should you have other applications such as, let's say, river crossings in a case of sewer force mains that need to be dual lined, for example, PRIMUS line is that choice, that flexible choice that will give you peace of mind. As well, the liner itself, as you can imagine, being from Kevlar, if there is any ground movement and stuff for the future, you have a material that has incredible tensile strengths. Another one was under the Danube, the river. That was a 272 meter shot, as well of 10-inch or DN250 as we call it. And again, SDR11 was chosen as the plastic for the hose pipe. As you can see here on the left is a hose pipe pulled through. Then our PRIMUS line is being inserted. And then obviously the connector are attached to that. Now here is a connector assembly for you technical folks out there. I can send you that on email. You can see that you have different I want to call them connector pieces as we join the liner being a reinforced thermoplastic onto a welded end made by us. So important is that the connector and the liner come from the same manufacturer, which is us. And then again, going through a transfusion piece, going onto the host steel pipe again. So that's quite, I think, quite interesting in this case. I'm quite happy that there is now over 15 projects have been realized on this particular site. Robert Golitz is our Chief Technical Officer that has been doing this now since about 2006. I urge the clients that are out there to reach out to us, for technical aspects, for questions, and to get into the conversations about this. I think it's time that we talk a little bit more, putting HDP across and then bringing a slip lining method such as, for example, our part, which is the RTP pipe, as a dual approach. Will save you costs, has lots of benefits. It's a much smaller borehole in case that you have to get closer to the river rather than being far away. A lot of environmental sensitive areas are there. You can also use it for railway crossings. It's quite versatile what we're doing. So for that, I'm done with my presentation. I thank you so much for inviting us to come online here. It's 20 minutes now into my presentation time. I want to turn this one over to Mike or to Megan. Go ahead.
Hi. Thanks for the great information so far. We did have a question pop up here, so we'll get right into it. And
Sure.
You briefly touched on it here at the end. Can you kind of maybe discuss a little bit more about the cost savings of using PRIMUS liner plus the HDPE pipe in comparison to using a lower DR HDPE pipe?
Yeah, 100%. Yeah, one can imagine that the material cost on HDPE is obviously quite lower than steel. Also, the method is quite lower as well. To get into the details of, let's say, okay, let's take a 100 or a 200 meter shot and say, okay, you're going to save yourself $1 million. we obviously, the audience has to understand one thing, which is very important. We do this ourselves. So we are an HDD drilling company. We're a manufacturing for the liner. Yeah. So we do it ourselves. So we don't do it through subcontracting. So we have these costs for when we are on our turf. So we can guide that conversation with clients that are online currently. The answer to this question is yes, 100%. There is big cost savings.
And is there a general rule of thumb when this dual method makes the most sense? Is it just for high pressure applications, or?
I would not use the word high pressure. I would actually use the word low to medium pressure. I would keep myself around the 400 psi ish MOPs. Yeah. So anything up to that, past that, there in North America, you will run into trouble with the DOTs and stuff. So, I'll say low to medium pressure is where it's at the moment. That's what we think. Sure, we can give you a high pressure application too at 800 psi. Yeah. However, we haven't been called to task for that yet. Mm-hmm. So go ahead.
Obviously, availability is an important question. So what is the availability of this material?
So we are located obviously in Germany. We manufacture. We have a distribution center in Batesville. So we're on the ground. So we have material on the ground in Canada as well as in the United States through our partners. Yeah. So the availability is absolutely there. Not a problem whatsoever. Now I just see a seismic activity question, actually quite interesting. We have a couple of studies, especially out of Italy with their seismic activity. They got quite a few. We also have a project over in Japan. They also have seismic activities. So that's actually, we have a write-up on the NASTT, I believe, back in 2018, I want to say. So for this question, I'd like someone to just reach out to me, please, and then I can give them that conversation piece. Yeah, we got white papers about that. Mike, back to you.
Great. Has the product been tested for gases other than natural gas? Example, hydrogen.
Thank you for the question. So hydrogen, obviously, being on the Richter scale, not the Richter scale, when it was seismic, on the scale being 1, being very it permeates. So we are in the R&D section at the moment. It will still be a while, but I will not comment on hydrogen at the moment. That this is still, as for the audience, and thank you for these questions. We are in R&D phase. Obviously, permeation is the number one thing on this part for us. So currently, we cannot announce anything out of the R&D section yet. We are working on that, absolutely, but nothing yet to share with the public.
How does a Kevlar-lined HDPE pipe compare to a thicker-walled, lower SDR HDPE standalone pipe? What are the benefits?
Well, look, I mean, in a standard HDPE wall, one has to imagine it's a thick wall, right? So that the load is always carried by that. So if there is any brittle factors in there, so it loses the load. Yeah, it loses the hoop strength. So this is why it makes sense. And actually, matter of fact, quite interesting. We just had this conversation not too long ago. I think it was Eastern Canada somewhere. That there should be some laws placed in role, especially for hazardous fluids, where you slip line or dual line an HDPE pipe when you drill it across the river. Especially if it's sewer, for example, and you want to make 100% certain that does not come, into the potable water side or the raw water side that is later on used for drinking water. So the flexibility of PRIMUS line being a 3-layer construction, having the hoop strengths of Kevlar, this is where it's at. There is no brittle factors in play or static things in play because we absorb those nanoshocks, we absorb those water hammers, and that's where the issue is with HDPE or PVC. Sorry to say that, but that's just the case. Go ahead, Mike.
What is the gas permeability rate for gas into the annulus?
100%, yeah. So this is a calculation, and then usually if you say you have one bar being 14.5 psi over a period of, let's say, 3 months, then that's what's measured between the monitoring pipes, and that's what's going to get vented on a maintenance procedure. The liner itself, the calculation, I don't have it in my head now what exactly that is per 100 psi based on the calculation. I have that obviously, and I can share that with the audience or with the individual that's interested in this, Mike. So we do have that, yeah, but it's a low permeability, yeah.
You mentioned that you've done these projects
yes,
abroad. Have you done any of these projects in Canada yet?
Yeah, so in Canada currently we line, I don't know, we're now at about 4 or 5 million feet of water pipe, of oil and gas pipes and stuff. So the dual approach, as I'm presenting to the audience, has not been done yet in North America. It's completely brand new thought idea. It's the brainchild of our chief director, Robert Golitz, online here. And this is what we saw. We bring to the University of Alberta, we bring to CUIIC, and we let the audience decide if they want to take it a step further. It works. It's been tried. It's in the ground since years. And I think it's time to look at it more closely here in North America. Mike?
Looking at HDD specifically, I think you should be able to answer this question. What soil conditions are best suited for the HDD? Are there any that have caused problems with this process?
Well, this is an HDD-related question. I mean, that would be something now that my engineer would answer, because this is, of course, the answer is yes. Yeah, 100%. That's what I can say for short, but that's a question that my engineering department answers, because obviously I know we're the client here that is asking us this question at the moment. Very valid question. The answer is yes.
Maybe Robert was supposed to join us on this webinar and was unable to connect. Perhaps you could share his contact info.
Oh, yes, 100% I will share. Robert has been with PRIMUS Line since 2006, is not just one of the people that is within, the people that are from the pipeline engineering group at PTAC over in Europe, sitting together with the profs and the engineers and putting that together. So Robert, I can definitely share that. And Mike, maybe you want to share that too, if you want to put that on. It's up to you.
I believe we have the information that we could share with everybody after the webinar is over. Yes.
Sounds very good. So we have 2 more minutes, I think, Mike. Am I correct?
Yes, that's correct. We like to wrap these up at about a half hour. So if anybody has any other questions, feel free to ask them really quick. Otherwise, we'll begin to wrap up today's conversation. See that the questions that we do have left are HDD focused, so we'll get them in contact with Robert.
Correct, or with myself, correct. It's a very good question. I can read it. Good question. Let's answer this one. Yeah. And I see this is from Fiona Pang out of Parkland, GEO.
Yes.
Yeah, certainly. Yeah. Will be my pleasure. Bring it all forward. I hope I get 1,000 questions after this is over.
Hopefully too. Hopefully. But, with that, I'll wrap this up. On behalf of CUIIC and Benjamin Media, I'd like to thank Alois and PRIMUS Line for presenting, and MPipe for their sponsorship of the CUIIC Webinar Series. Most importantly, I'd like to thank everyone who was able to attend today's webinar. We look forward to seeing you online July 20th for the next CUIIC Academy webinar, and in person in Edmonton this November. Remember to visit academy.cuiic.ca to get more information on all these exciting educational opportunities. Again, thank you, Alois, for presenting today. Hope everybody has a great day. Take care.
Thank you, Mike. Thanks to the audience. Thank you to CUIIC. Have a good day all.